All right, titration. So titration, you might remember from reagents, is the process of when we add a known amount of either our acid or base to the other one to do a neutralization reaction. And then we have the formula MABA equals MBBB. So basically we use that formula and we solve for one of those. So you would know 3 of them, you would solve for the 4th variable. Now, we can actually use titration for a lot of things, not just acid-base calculations. So this is an example of doing a titration with something that's not an acid-base problem. So here what we're doing is we are looking at the amount of chloride present in a water supply. So we know that we have chloride present in our water to kill off bacteria, but it can't be too high. There's a certain level of chloride that they need to maintain. It can't be too low, can't be too high. So one of the ways that they test for that is they add silver ions to the water, which would make lead chloride, which would then precipitate out. So then you would have a solid. You could figure out how much solid you had by taking the mass of the solid. And then from there, you could figure out the moles of the solid that were produced, and then the moles of the chloride that were produced. And from there, you could also figure out its molarity. So how many grams of chloride ions are present in a sample of the water if 20.2 milliliters of 0.1 silver ions is required to react with all the chloride in the sample? Okay, so our equation was already written for us, so we don't have to do that. So your next step is always find moles. So from what we're given, we want to find moles. So we have molarity, so that's going to be 0.1. We have our volume, except molarity has to be in liters. And that color is not showing up at all, so I will redo that. So we have the 0.1 molar solution, and we got to have liters down at the bottom. So 20.2 milliliters would be 0.202 liters. Okay, that would give us 0.00202 moles. And that was the silver ion. So that would be helpful to include that. So if I have my moles of silver, I would know how much chlorine I have too, because they're in a 1-to-1 mole ratio. Therefore, the the chloride concentration, or the chloride ion, is equal to 0.00202 moles. Again, we don't want to just throw down numbers, so we would say because they're in a 1-to-1 mole ratio. Okay, if I have moles of chloride, I could certainly turn that into grams of chloride. So I would just take that 0.00202 moles of chloride that I have and multiply by the mass of chlorine. Now we have the chloride ion, but that just means it has an extra electron. That doesn't affect its mass, so that mass would still be 35.45. So we just multiply those two together. And we get 0.0717 once that is all rounded, because we do want 3 significant figures. So 0.717 grams of chloride. Again, like I said, we could have found other things from this. If we had a volume, then we could find the concentration of the chloride. But grams is what our question was asking us to find. This is just going through that, the calculation written out if you need to see anything. Notice this is set up a little bit differently. This is how your textbook would set it up. Either way is perfectly correct because we end up with the same answer either way. All right, so now we've got another one here. What is the molarity of the sodium hydroxide solution if 48 milliliters is needed to neutralize 35 milliliters of 0.144 molar sulfuric acid? Okay, two different ways we can do this problem. Way one, this is how your textbook will do it. Write the equation, balance the equation, find the moles of sulfuric acid. From moles of sulfuric acid, go to moles of sodium hydroxide. If you have moles and volume of sodium hydroxide, you could find molarity. Or if you recognize this is a titration problem, we can just plug this on into MAVA. And this is going to be a little bit quicker, but either way will work. If we do this though, we do have to account for something. We really need to multiply by the number of hydrogen ions present in solution and by the number of hydroxide ions present in solution, because the mole ratio would take that into account if we were writing out our reaction. So we have sulfuric acid. Sulfuric acid is H2SO4. So that would give us 2 hydrogen ions. The molarity of the sulfuric acid is 0.144. The volume of the sulfuric acid is 35 milliliters. All right, the molarity of the base is the thing that we are looking for. Volume of the base is 48 milliliters. And there is only 1 hydroxide ion present in the base because it's NaOH. So now we just do our math to figure out the molarity of the base. And we get 0.21, and we wanted 3 significant figures, so we will add that 0 in. So that way works, but you also could have done it like your textbook will do it. Write the equation, balance the equation, find the moles of acid present using your mole ratio, find the moles of base. If you have the moles and the volume, you can find your molarity and you would come out to have that answer. All right, since this is the end of our chapter, I just want to take a brief second to review a couple of things that we have done. A combustion reaction is when we combine anything with oxygen. A lot of times it's a organic molecule, so organic plus oxygen is going to make carbon dioxide and water. A metal with oxygen is just going to make the metal oxide. So if it was iron plus oxygen, it would make iron oxide, and it would depend upon if it was iron 2 or iron 3 oxide, what the formula was. So those are some examples of some combustions. Carbonate decomposition. So that one's a little bit different. When we have our carbonate ions, then we are going to make carbon dioxide gas, and we're going to do a lab with that. Neutralization, acid plus base, makes water and an ionic salt. We're usually pretty good with that one. Carbonates and bicarbonates with an acid. Neutralization, you additionally make carbon dioxide gas. So we have our water, our salt, and the carbon dioxide gas. When we react a metal with an acid, we produce hydrogen gas, so we will see bubbling. Single replacement reaction, when we have a metal and an ionic salt. And that is it. So now we need to start reviewing for chapter 4 so that we can prepare for our test.